Okay, this last question that I've included here is actually something which is off a VCAA exam from a couple of years ago. So I thought it would be a good one to include just because it's a little bit different, a little bit more challenging perhaps than some of your standard questions. So here it is. So y equals sine x and y equals a cos x intersect at x equals pi on 3, and we need to find out what the value of a is. Now, what I'm going to do is I'm going to give you a few minutes, I'm going to give you a few minutes by you pausing the video to have a go at this question, and then I'm going to actually work through the solution. So if you just pause the video now, have a go, see what you come up with, and then I will show you how to do the rest of the problem. Anyway, I'll give you a few seconds. Righto, now I'm going to work through this question. So to start off with, well, I know that these graphs intersect each other. I could just try putting them equal to each other. So I could go sine x equals a cos x. That's a good start. Okay, we know that they intersect when x equals 3. So I can go, sorry, when x equals pi on 3. So I can just go sine of pi on 3 equals a cos of pi on 3. A couple of different ways that you could do this. You could combine the sine and cos together to make it into a tan function, which is actually what I'm going to do. So I'm going to divide both sides by cos. So sine of pi on 3 over cos of pi on 3 is equal to a. So that means a equals tan of pi on 3. And because we know the exact values, we know that tan of pi on 3 is just the square root of 3, so we can say that a is equal to the square root of 3. And that would be your answer. I have a feeling on the actual exam the question was the other way around, but well, anyway, it doesn't make a real lot of difference. Still similar idea. Alternative working, if you had sine of pi on 3 equals a cos of pi on 3, we can know these exact values as well. So sine of pi on 3 is root 3 on 2 equals a times cos of pi on 3 is half. So, well, we can see that it's got the over 2 part here. It's just that this here should be actually a root 3, so we need to multiply it by root 3 here. Okay, so that means that a equals root 3. Again, arriving at the same solution. Or alternatively, you could have just multiplied this here by 2, and that would have given you the same solution as well. Anyway, I'll leave it there. See you later, guys.